So to honor this section of ecology, the cycles of matter, I thought I might have a little throwback and wear my uniform from when I used to race. Get it? Cycles of matter. But again, this isn't really cycles of Kevin, this is more like cycles of matter. So, but I do need to sort of cycle through some puns. I know, you probably want me to give you a break. So what I think we're going to do is we're going to go ahead and shift onto something more scientific. So without further ado, cycles of matter, and we'll leave cycles of Kevin behind. All right, I know, cycles of matter. So first of all, what is a cycle? Not a Kevin cycle, cycle of matter. All right, a cycle is a process that repeats. And as long as all the components stay the same, the cycle continues. So actually, I know I wasn't going to talk about much bike stuff here, but I couldn't resist. So if you think about a wheel, it goes around and around and around, okay? So if a component of that wheel changes, meaning you take away the rim or you take away the spokes, the wheel will no longer go around and around. So for a cycle to be successful, all the components need to stay the same. So it's kind of like recycling. All right, so there's 4 types of cycles in an ecosystem. The first is the water cycle. The second is the nitrogen cycle. The third is the oxygen cycle. Fourth is the carbon cycle. So for this video, we're going to talk specifically about the water cycle and the nitrogen cycle. So first, the water cycle. So the stages of the water cycle. The first is condensation. The second is precipitation. The third is accumulation. The fourth is evaporation. And the fifth is transpiration. So one thing that's kind of easy, you've probably already picked up on this with the water cycle, is it's all about the shuns, the T-I-O-Ns. But one thing you should never do really is you shouldn't shun the cycle. Ha. All right, first, condensation. So as water vapor gives back its energy, it cools. So if you think about like the water on a stove, you've got the flame that's going underneath the water. It's exchanging, it's giving its energy to that water, and the water is changing form and becoming vapor. So as the vapor cools, as the energy goes away, it cools. And what happens when that happens is it forms tiny drops. It condenses. All right, precipitation. This is when more water comes together. So you've got the vapor that's cooling off, forming the tiny water droplets. Those droplets come together and form precipitation. So more water comes together. The water gets heavy enough to fall. Depending on the temperature, this can be rain, it can be sleet, it can be hail, or it can be snow. Now this lands on the ground, which leads to accumulation. So the water falls from the clouds in snow, rain, sleet, or hail. It can be runoff from snowmelt in the mountains. What happens then is it collects or accumulates to form lakes, rivers, streams, and the ocean. That's accumulation. Evaporation. Water absorbs energy and changes to gas. So this comes from bodies of water. So you're kind of catching on, right? It's kind of a cycle. So the water comes down, it accumulates, and then it's kind of hanging out there, waiting for some energy. In this case, the water wouldn't necessarily be energy from the stove. You know, we were talking about the stove boiling the water. This would be energy from the sun. All right, so the water absorbs energy, changes to gas. So bodies of water, lakes, streams, all that. And also, when you exhale, you actually exhale vapor as well. All right, transpiration. So this is water that evaporates off the leaves of plants. It's kind of like plant sweat. So you can't see it with the naked eye, but it actually is still occurring. In fact, a large oak tree can transpire up to 40,000 gallons of water a year. It's sort of part of its respiration, so to speak, its photosynthesis is transpiration. All right, so here we have the water cycle. And I'm going to go ahead and get out of the way here. Riding away. All right, so where should we start here? Let's start with the groundwater right down here. Then we're going to head to evaporation from the oceans, lakes, and streams. heads into forming clouds, which is also joined by the transpiration from plants. Then the water gets really heavy, depending on the temperature. It comes back down as precipitation and runs back into the water supply. So, that is the water cycle. All right, I'm back. So, hope you guys dug on the water cycle. Moving quickly on to the nitrogen cycle. All right, so first, nitrogen is a building block. It's N2. So nitrogen, and this is very important, nitrogen is the key component of chlorophyll. It's a very, very key element of chlorophyll. No chlorophyll, no photosynthesis. And as you know, no photosynthesis, no plants. Take away plants, we're all kind of in big trouble. All right, so actually the air we breathe is composed of approximately 78% nitrogen. It's quite a bit. So it is inert, meaning it really doesn't really like to bond. So it's like, man, you know, I'm just kind of okay, I really, really don't need you. So it's really difficult to get out of the air because it just kind of wants to stay right where it is. It's very inert. So to get it out of the air, you need to do what is called fixation. So you need to fix the nitrogen. And what happens with this is it combines with other elements. This is frequently performed by bacteria, like the nodules in plant roots, like legumes. Legumes are beans. So you've got those cute little legumes, and then you've got the cute little roots that are holding the cute little legumes in the ground, giving it a little bit of nutrients. That helps convert the nitrogen into something that is usable by the plants. Also, and I think this is kind of cool, is that nitrogen in the air, when lightning, electricity will help bond the N2, the nitrogen, into usable blocks. So whenever you see lightning, know that there's nitrogen fixation going on. All right, the nitrogen cycle. So the first thing you have free nitrogen, which begins in the air. Then the plants absorb this free nitrogen from the air when there's lightning, or use the bacteria and plant roots to fix the nitrogen, those cute little legumes, beans. Then what happens is the consumers eat the nitrogen in the producers. So remember, the producers are the plants, and the consumers would be, in this case, maybe, let's go with the cow. Then they eat the plant, they eat the producer, and they poop the nitrogen back into the soil, where the soil bacteria release the free nitrogen back into the air and break the nitrogen down completely again. So soil bacteria, think of those as decomposers. And the cycle continues. So here we have the nitrogen cycle. Again, going to get out of the way. All right, so on this one, let's go ahead and start with nitrogen in the atmosphere, which is going to kind of be hanging out, doing its thing, doing its nitrogen thing, being all inert. Then, boom, lightning strikes. Now you have usable blocks of nitrogen. So the plants are going to be able to absorb it. And also you have the nitrogen in the plant proteins right here. Nitrogen in the animal proteins, which means, that's when they sort of eat it and poop it back out, which goes into the ground. You've got nitrogen right here in decaying matter and waste. Now this sort of seeps into the ground, and then the bacteria can convert it. They fix the nitrogen for use by the plants, and the plants gobble it up, and then the animals, consumers, eat the plants, the producers, and the cycle begins again. All right, so I had to end, since we had a theme here. This is the nitrogen cycle, a really, really long tandem. So here are some of our components. We've got the sun. We've got, I'm going with that, a tree, maybe a broccoli, I don't know, that is going to be one of the producers. We've got a couple consumers, and then on the far end of the tandem here, we've got the decomposers that are going to break the nitrogen back down into its most simple form, getting ready to be fixed nitrogen fixation once again. So hope you liked this, this cycle, the water and nitrogen cycle. And, you know, remember kids, always wear your helmet. You only got one brain. Bye.